Okay. Sorry, I don't know. When I pressed the mute. Oh yeah, thank you, Anin. I was searching what I was thinking. I mean, what the question I was asking. So thank you very much. Yeah. So why does it have to be ethanol to remove the bubbles or any alcohol? My first question is, why do we have to use ethanol to, how does it, help to remove the bubbles? So to understand that, to understand that, we have to know why at first the bubble is being formed, right? Why is the bubble is being formed at the beginning? So this is a research question that we should have in our mind, that okay, we are adding alcohol, ethanol, to remove the bubble, but why the bubble is coming in the first place, right? So this is the way of causation, that we try to understand what is the effect and what is the cause for that. So yeah, bubbles are being formed if alcohol, then to increase the molecular force. Okay, I like this answer, and it is a great that you tried, and I want everyone to try. There is no we are not forcing you anybody, but it is good that you talk. Ethanol is more volatile than water, so can remove the bubbles. Great, great. Nice thought. I really like it. So first the question is why the bubble are being formed. What is the bubble? Bubble is a bubble, right? There is air inside, and it is trapped in the the air. The air is trapped inside a film, very thin film. So that is the bubble. That is how bubble is being formed. And for this case, very small amount of air is being added or is being trapped in kind of the liquid film that is produced from the juice of lemon. So why is that they are producing a film? So film, it's kind of polymer thing, right? We understand that there should be something surface tension it will have. So the surface tension is very heavy, and that is why they are forming membrane type of thing. So they are forming a film type of thing or membrane, and then the air being trapped inside. That is called the bubble. And so this is the cause. So how can I help not to form that type of film or that type of surface tension? I want to reduce the surface tension. If I can reduce the surface tension, or if I do not allow it to form a polymeric, very thin film, if there is no thin film, then there will be no bubble. So that is the research that this is how the researcher should work. So for this case, just now, Irene says that if alcohol, then to increase the molecular force, okay? And Gabriel says that ethanol is more volatile than water, so yes, both answers are good. Alcohol is bigger molecule than water, right? Alcohol is bigger than water, the molecule. We know that H2O is water and CH3CH2OH is the alcohol. And it is more volatile than water. Yes, that is true as well. And that is why it reduces the surface tension of water, or not water, in fact, the surface tension of the molecules of the juice that is forming the polymeric film because of the surface tension, it reduces rupture. It breaks that molecular bonding between them, and to remove the surface tension. When there is no surface tension, it cannot form the polymer, and then that is how the air cannot be trapped inside. So another question came that why must be ethanol? Cannot be any alcohol? Yeah, it can be methanol as well. But in our lab, probably we don't have methanol, first of all. And second, it can be propanol, but it cannot go beyond a very long chain carbon alcohol, what we call long chain carbon alcohol. Just to remember this thing, we don't have scope here to talk because we will be talking about it in our organic chemistry. So long chain carbon alcohol is something that it has a long chain CH2, 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 but when it is very long, it will be alcohol as well, but it will not be dissolved in water. They themselves will form a problem. I'm not going to explain it now. I'll talk to you about it later when we talk about the organic chemistry. So don't be worried. But if you want to know more about it, please remind me that time, Heinin or Gabriel or anyone, so that, because I'm sure that I'll forget about it. But if you please remind me, probably we can discuss later on. Okay. So this is why we have to use alcohol, ethanol, to remove the surface. Methanol, by the way, that I said that other alcohol, methanol can be used. Yes, methanol can be used, but ethanol has a bigger molecular carbon chain than methanol, so ethanol works better, and ethanol is safe to use. Okay, so yeah, any other question anybody has? No question. Okay, so let's go to the measurement tutorial and then we will talk about the concept invention. Quantitative, right? Quantitative analysis. Can anybody tell me what is the difference between quantitative and qualitative? Those, I'm expecting it from those who are already from foundation. I'm sure that you have heard, you remember, I don't know whether you remember, but you have done this. Quantitative and qualitative. Anybody can answer me, please? Sorry, Gabriel, quantitative can be measured. Yes, thank you. Good. I mean, quantitative means quantity that we can quantify. All right, that we can quantify, and qualitative means we only can feel the quality, but we cannot quantify. So this measurement, of course, it is not coming for qualitative thing, but for quantitative thing. And for quantitative, yeah, Gabriel, thank you very much for the answer as well. And only for quantitative thing, we will have the values, or we will have this figures, right? We'll have the figures for quantitative thing. Okay, we'll have the figures for the values in that. And when it comes for measurement, precision, accuracy, how good the result it is, how much we can accept that result, those things also come along. So the accuracy is how precise is the result to the standard or to the true value if we do not know the true value to the standard value, how precise it is, or how, remember that the dart board game that we showed in the previous, during the lectures class, that how many darts are hitting the bullseye. There is the accuracy. So that is the precision. That is the precision. Wait, hold on. No, that is the accuracy. Yes, I'm sure. So how much your result is very much, close to the true value is the accuracy. How accurate is your result? But precise, because most of the time we will not be doing only one or two experiment, but many experiments to get the result is okay, or just to be sure that these results are really giving us we are getting close to the accurate result, or close to the true values. So we will be doing many experiments, and if all those results or data we are getting in a very precise place or any certain place, then we call it precision. So percent of uncertainty, and when we are doing the precision, when we are doing the many experiment or many trials on the same experiment, sorry, yeah, many trials for the same experiment, there is a chance that we will get the results. One is one is 10 more, another one is 5 less, in that way. So in both side, more or less, we'll get the results. So percentage uncertainty is also depends when we are talking about the accuracy and precision. So uncertainty is a measured values. Percentage uncertainty is uncertainty over the measured values times 100% relative standard deviation. So we have to find the standard deviation first, and that is the average number of the data that we are taking, 100%. And when we are doing this type of thing, there are two types of error is occurring. That is, one is systematic, another one is random. What is that? I'm not going to talk much of these. First of all, let me go through this systematic and random error. What is that? Oh yeah, we have it here. So there will be two types of error occurring when we are doing the measurement. Another thing is for the tolerance or for the uncertainty, when we will be calculating uncertainty, always added up. Remember that uncertainty always added up for addition and subtraction. For division and multiplication, the uncertainty always also added up, but in a fraction of values, or in relation to the main reading. The the error is added up. So this is the experiment or the calculation that I hope that you have taken care, or you have seen it before, or from you have tried at home, in fact. So that it should be good for you to try. And then systematic error and random error. So when we are doing the experiment, there are two types of error that they will arise. Systematic error, that it is happening when there is the error is occurring from in all direction. That means okay, in one single directional measured value is lower than the accepted value. For instance, systematic error is the experiment will produce inaccurate result with high percent of error. So systematic error is occurring when there is some problem with your glassware or some problem with your instruments, some problem with your what do you call it, standardization process, or maybe some process with your chemical itself. And then since those problems are already there and you cannot remove those problems just by, just by shaking those things or by keeping it there, you have to rectify those problems if you want to remove those error. So the values that we will get is always one directional. The error should always be one direction. Like if you are doing the titration, for example, I'm giving an example for systematic error. If you are doing a titration like yesterday and your sodium hydroxide, it is not 0.1, or there is some impurities in the sodium hydroxide, okay? There are some impurities in sodium hydroxide, and then you are doing the titration with that sodium hydroxide. So what will happen? No matter how many times you do the titration, you will always get the similar type of result. Either you will get very high value of the titrant or very less titrant value, right? It depends on what type of impurity you have. You cannot, 1,000 times you do the experiment, the result will always be either high or low. You will not get one is very high, another is very low result, right? If there is any impurity in the sodium hydroxide. Same goes for the juice as well. If you are taking the juice and there are some problem with the juice or inside the juice, you cannot get one is very good result or a positive result, one is very negative. You will always get a similar type of result. So that is called a systematic error. So calibration, if we do not do the standardization, the chemical problem, undesirable side reactions, like you put the sodium hydroxide in air for a long time with an open container, what will happen? You will always, the sodium hydroxide is not high, it's a hygroscopic, and it reacts with the carbon dioxide in the air. It will get sodium carbonate, or it will lose its strength, or not molarity. Yeah, it will lose its molarity. So it is not 0.1 molar anymore, or it is not 0.2 or 0.3 or 0.5, whatever you made, it is not that anymore. And you are using it, so all the time it is giving you the same type of result. So this is called systematic error. We cannot, by repeating the experiment many times, we will not get rid of this type of error. It will always give us the, but for random error that we do not have our hands on it, or we cannot remove the things that the error is occurring. So those are called the random error. Any environmental factor, temperature, humidity, fluctuation of voltage in electrical instrument, or the air pressure suddenly drops or suddenly high, and then what else? The ambient light, right? So suddenly it starts raining or very dark. So the light is reduced, although we can increase, switch on the lights in fact, but let's say that we need UV, right? We need the sun, UV, direct sunlight, but suddenly there is overcast with cloud and the UV is not that high that we wanted, so it is not in our hand. And inconsistent observation techniques, parallax error. Can you tell me what is the parallax error? Yeah. Anyone wants to chip in? What is the parallax error? parallax, incorrect eye position to the scale reading. Yes, good. Or scale reading or the level of the graduation for pipette or for burette or yeah for whatever your eyes is not in the same horizontal level as to the surface of the materials you are measuring, so that is called parallax error. And that is why it is a random error. So if one group, we are three students in one group, and there are three students. One is very tall, one is average, and one is not that tall. So three of us, if we look, you will see that our eyes are not in the same horizontal level. It is like this. One is looking from here, this part, one is from here, another one is from here. So we are not looking parallelly and that is how the parasite can occur. So yeah, we can remove by doing the measuring it over again. Application. Those type of measurement consideration that we can apply for electric balance, and then for this type of balance there are okay. Triple beam balance and electronic balance are two types of balances that are used in laboratory to measure weight. Electronic balance, triple beam balance. Please record mass from the following measurement of two objects. So what is the mass for two objects? Here for electronic measurement, it is giving us 200.00. For a triple beam balance, what will be the measurement for this thing? Okay. Okay. So what will be the measurement for this thing? And can anybody guess? Let's try to guess. Can anybody guess what will be the measurement for triple? We understand it is easy to get what the electronic balance is giving us, but what will be for that, what do you call it, for triple beam? Anyone? 300 plus, yes, yes. 300 plus, but what exactly the value? This is 200. We understand this is 200. Take so where is the person? Yeah. So this is 200. We understand. This is 200, and then 0.00 exact gram it is showing us. And what will be the uncertainty for this? Can anybody tell me? What is the uncertainty for this? Somebody replied. Yes, 0.01, Gabriel. Thank you. So 0.01. Anyway, so this is the uncertainty for the electronic balance. What about for this triple beam balance? What is the mass or weight for that object? So this is 300 that we understand. Excuse me, my writing. Somebody replied here. Oh, okay. So for the triple beam balance, anybody? Can you see how much is that? So this is this is the gram, and this is also a gram, this is also a gram, right? So for this, we will see 300 is here, the main room balance is showing this 300, and the subsection is showing is 70. Another section is showing 3, I mean 3 past how much? 1, 2, oh, come on. So 1, 2, 3. So 3.3 is gone. Out of 500 gram, it will be 300 gram. Out of 100, it is 70. And out of 10 gram, it is 3.123, right? After 3, it is even, the slide is even more than the 3. So let me check if anybody, 0.05, yes, Gabriel is good. But how it is coming, I will explain a bit how it is coming. So it is 375, 300 plus 70 plus 3, right? Because 300 gram plus 70 gram plus 3 gram already passed, and then there is the subsection is, it is 73 plus another it's the bar slides to even more, so 3.5, let's say 3.5 plus this one, which is that the one section, right? One section is showing one graduation of 1. So uncertainty for this not, I mean, analog machine, that is not digital machine, is the one section by divided by 2. So it will be 0.05. The section value is 0.05. So in this way, we'll find that, let me write it in a better way. So 373.35 plus minus, so 373 plus 3.5. It is in between, the slide bar is in between 1 and in between the 2 marking in 2 graduation point, but we do not know exactly where. So you have 3.35 plus minus 0. Plus minus is given, so 0.05. So this is the measuring. Nowadays, you will not see many of this type of instrument anymore, unless you go for really a very big measuring things, that is the iron bar, big chunks of concrete are being measured. Otherwise, mostly we use this digital type of things. So which is more precise? Of course, this is 0.01 and this is 0.05. So this is more precise because it goes to a more smaller precise result, right? It goes to the more precise result. Question B says, in a class, 8 groups of students are required to weigh. Okay, before that, before we move on, do you have any question for this type of problem? For this problem, anybody has any question? No. Okay, calling once. Second and third, no. Okay, so In a class, 8 groups of students are required to weigh an iron block using these two different types of balances. The following is the weighing data uh, for the students. Table 1, mass of an iron block is in gram measured using an electronic balance and the triple beam balance. Group 1, the measured 156.14, 156 0.08, group 2 13, 18, 12. Yeah, so this is what will be the average. So we'll just sum it up and then divide by how many, 8 different measurements we have, not by different groups, because if in between it was tabulated in this table and somehow let's say that this group did not give any result. Let's say group 4 did not give any result. So I would sum these 7 data up and then I would divide by 7, not by the group, but the available data that we have. So electronic balance will find the average and the triple balance will find the average. The deviation, average deviation will be the, let me find out what is the total mean average mass of this is for this electronic balance we are finding 156.14, something like that. 156.14. And for this we will find it is 156.03. 156.03. All right, so this is the average mass for triple BAM and for the electronic mass. Average deviation, how do we do the average deviation? So we will take these each single data and then minus this average mass plus the same thing for the second group data or second data plus the third data plus the fourth data, same thing. We'll we'll deduct this average mass from each of them and then we'll sum it up and then divide by the total number of the value that we have. So the electronic balance, it is showing the 0.01. If we do in that way, 0.01, the average deviation, and 0.06 for this triple beam balance, average deviation. But this is good. And at the end, plus minus 0.01 should be good to serve us our purpose. 0.01. So this is the total value, including the average deviation. So the tolerance, 0.06. 0.06. So this will be the total value, total measured value for that. Iron bar, sorry. And okay. So we have 8 data, right? If we did not do the average deviation, we could still do, or we could do the standard deviation as well, and that would be okay because we have 8 data set. If we had only 3 or 2 or 4, then average standard deviation would be problematic. So in that case, we would be doing average deviation. But in this case, average deviation is acceptable. But when we have that many data, 8, 10, 15, then standard deviation is better to do. So what type of error occurred for these two types of balances? So for electronic balance, what type of error could have happened that gave us this type of error in our experiment? Random or systematic? For electronic balance, did we have systematic error? Could we have systematic error that we could have rectified by using many different type of experiment? Could we have? Anybody? Can anybody just what is your guess? What type of error we had for electronic balance? Systematic error or a random error? Gabriel says no, random. All right, thank you. Gabriel has his own, and it is okay, and this is good actually, it's correct. But if anybody wants to say that no, there is a systematic error, Audrey says that can be systematic if the electronic balance is not calibrated properly. Okay, that's great. Great. All right. Okay. Anybody else want to chip in? For this is the electronic balance, right? We are expected to put the object here at the center, right? We are expected to put the in the center. Sorry, but if somebody is a bit not serious type and he or she is just passing the time in the lab, just put the thing here, right? Is not even caring where he is or she is putting the thing here, or did not take note whether there is a lot of dust or other materials is stubbed inside here, and then the balance is not totally free to move. So that is the systematic error that can happen. But this is careful. This is, we cannot say in that way that systematic error, because this is a carelessness. This is a carelessness. You can say it is an activity of experimental activities, human error. It will be a human error. It is, you cannot put it simply in the systematic error. Okay, because it is due to the carelessness of the people, and in scientific experiment, this type of personal error, carelessness especially, is not acceptable. You must be very careful in doing the experiment, because on your experiment, some quality of the product or the or someone else's comfort is living on your hands, so you have to be very careful in that. So there will be a random error in this thing. Systematic error, yes, if you do not do the calibration properly, so there will be systematic error for both cases, but mostly it will be random error, because the electricity may fluctuate beyond our control, or the air pressure may drop or increase beyond our control. So that is the random error. Same goes for this triple beam balance as well. But the parallax error here, it can occur for this type of beam. The beam, I will see one way, you will see maybe another way, or maybe my eyesight, your eyesight will be different. So there can be a parallax error, a bit of parallax error in this case. Okay. Now go to the second question. Which prebalance produces more precise measurement? Justify your choice. Of course, the electronic balance it will showing. Evaluating accuracy of measurement based on the average mass of iron block obtained from the two different balances. Can we tell which balance is more accurate? Why and why not? So we cannot tell. Oh no, sorry. We can, right? Where is it? We can tell which balance is more precise. Can we tell which balance is more precise? Anybody wants to vouch for any of the balance? Which one do you like more? and then think that, okay, this is the perfect one. It will give us the best result. Can? Isn't it the electronic balance that will give us the best result? Yes, Chirikan, I am thinking along with your thought, Gabriel. Okay, that means we are not only two. Anyone else? What about Baron, Jonathan, then Ezra, electronic good. Well, who else is here? Kishwan, you guys are there, right? So for what your vote will be, electronic or the triple beam? I understand that electronic balance, yeah, sorry, Varun, yeah, thank you. So I understand that electronic balance is much more sophisticated. It is giving us a better result. But the thing is, what is the actual value of the iron bar? It is not given, right? It is not given here. You did not notice. So since the actual weight of the iron bar is not given here, we cannot say that this balance is giving us the precise, accurate result. We cannot say that way because there is no way there to confirm what is the mass of the weight. But yes, generally electronic balance is giving us better result, much precise result, accurate result. But since we do not know the actual mass of the iron bar, we cannot vouch for any of those electronic balance. We have to be open-minded that, okay, it may be true. Yeah, we know that electronic balance is good, but in this case, maybe this is giving us the better result because we do not know which is the correct answer is giving. So yeah, so that is what. Um, Question number 2 saying that assume the iron block is made of pure iron and the volume of iron block is 19.83 gram cubic centimeter. Calculate the accepted true value of mass for the iron block. How can we do that? Do we know that M equals density, let's say D or rho times volume, right? This is the volume and this is the density. The density of the iron bar is given and the volume of the iron bar is given too. And then if we multiply both of these things, this centimeter cube will be cancelled out from a side and only the gram will stay. So this will be the gram, the mass of the iron bar will be there. Why is the difference between measuring values and true or accepted value? Is the difference caused by random error systematic? How to reduce the error? Okay, so the question is says that why is the difference between measured value and true value? Is the difference caused by random error or systematic error? How how to reduce the error? Simply is asking that why do we have this type of error, right? Or different measured values. So the difference between the measured and the true values is based on the systematic, because we are not having the random error here. This is the systematic error inherited in the measuring of the instrument, that is the balance. And to reduce this error, we need to calibrate. We cannot just remove it by doing it many times. We we have to rectify this problem from this instrument. If we do the percentage of error from this, the percentage of error from this, yeah. Okay, so if we do the calculation from here, the percentage of error, you will find out, you will see that there are difference in error, and triple balance is giving us better, I mean, more error, I think, if I'm not mistaken, and the electronic balance is giving us better result, less error, so probably is because of this calibration purpose is giving us. If a group of students heat the iron block before weighing, how this will affect the mass value they get and why? What do you think? If we what do you call it, heat it up, we put it in fire for some time or heat in some other way, so will that be different? Will that mass will be different? Will the mass be different if the iron bar is hot? What is your, I mean, what do you think? Is it higher or lower? Okay, the mass will be different. Okay, good. Gabriel says that he thinks the mass will be different. Will that be different, the mass? Okay, when it's already 10:13, 10:15, when we are measuring one thing, we are inside the air, right? Me and you and everything is inside the air, and air is a medium, and it has its own density, it has its own buoyancy things, and if it is, everything is you know that what do you call it, it is like a liquid thing, or it's a medium, how do you call it, this term, I forgot exactly what's the term. The air works as a medium. Yeah, that is the thing, the medium. They're like water. If we are taking something in the water, it is much lighter than what we are weighing in the air first. But I mean, it is, what do you call it, consider that it is not a water, we are weighing the things, or we are taking the thing in honey, inside honey. So it will be much more lighter in that way, because honey is much more thicker, right, than water. So that is my point, is that if we make it hot, the iron bar will become hotter, and the air inside it will have some buoyancy effect, because the air, surround air, right? The surround air will be hotter for this. So the mass of iron block will be lower than the true value. It will be less than the average value that we got, because of that buoyancy effect. It will put on weighting pan that this, I mean, the hot air block, when you put it on the scale of the balance, the air inside around it will be pulled down because of the hot buoyancy effect, and that is how it will be, the mass will be recorded as lower, with the lower than what it is actual value. So yeah, if we do this, evaluating practicality and cost effectiveness For the price of electronic balance is $380. Triple balance is less than half of it. Is the electronic balance worth the worth the extra money? Support your claim by comparing their precision, accuracy, capacity, cost, and convenience. Where possible, provide quantitative evidence from the experimental result. So this question D is a very practical question. Although it is not, this type of question will, most of the time it will not be, I mean, sometimes can, but most of the time it will not, you will not face in during your studies, but just after you go out to study or you do some project, these type of questions are very much common, that it is giving a case study to you that this is the difference. Why do you think option A is better than option B? Better in that sense of money, time, effort, convenience, everything. Why do you want to go for option A? Explain why. So this type of project, you have to submit the project afterwards. So this type of question is very much practical question. And yeah, so for your case, I'm sure now that or you are already understood, or you already have the idea that yes, it is worthy to go for the electronic balance. Okay, it's worthy to go for the electronic balance because even though it is double or more than double, but it is better in that way. It is much more accurate. It's much more precise. It is convenient to use, and yeah, it is worthy in that sense. So it is good to go for that. All right, so the practice question now. Most of the time there will be in other tutorial, there will be worked out examples and some practice questions. So the worked out is from today is the difference, because the first tutorial I wanted to also inform you about the way that we will prepare our lab report. But since it's the first day, I just went through the worked example, and now I'm going to a practice question. But later on, for other tutorials, I will not go through the worked example. You will see, I mean, you have to do your worked example for yourself. If you have any question, of course, you can ask, then we can discuss about it. Okay, so for the practice question, report the length of the stick measured by a ruler A and B. So this is ruler A, this is ruler B. Which is more precise? Of course, ruler B is more precise because it is graduated. One segment or 1 centimeter or 1 inch is divided into many other smaller segments, so that we know exactly what is the value. For ruler A, it is 4 point something. 4 point something. It is not 5, it is S. But for this, we understand that it is 4 point 1, 2, 3, 4, 5, 6, 7, 8. 4.8. 4.8 plus minus half of it. I don't know, is 10 times is divided, so it will be 0.05, right? It will be like that. But this one is 4 plus minus 1, because this is the difference. So plus minus 1. It is not that precise anymore. It's not precise at all. So the average volume, average deviation, you have to do it all together. Suppose we have obtained the following values for the mass and length of a cylinder and compute its density. It's the same thing that we have done in the lecture slide previously. So I think that you can go and try. It is the same thing actually, but you can try to solve it. It will be good practice. unless you try, you will not find what is the problem here. So that the problem will be a problem for you and it will not be solved. So please try. If there is a problem or if you do not know, just ask the question. It is good. We learn more by asking question, okay, or discussing. For groups of students have done a calorimetric experiment, question number 4, sorry. 4 groups of students have done a calorimetric experiment to determine the enthalpy change of a reaction in aqueous solution, for which the literature value is 38.73 kilojoule per mole. The values found by the group in kilojoule per mole were 35.1. I mean, these are the values that we have found. And remember, this is the enthalpy, that means the measurement of heat. So in my opinion, or in your opinion, what is the main problem here? We see that group 1, group B, group C, group D, all of them are having a very big difference. 35 to 36, 33, and then 34. So it's a big difference. What is the problem? What could be the problem? What do we think that could be a problem in this experiment, right? So is it a random error or a systematic error? Both random and systematic error. It is not possible to tell from the data given. It is possible to tell from the data given, but it is possible to know from the data given by looking at the total values here. 38.73. See that none of the values are higher than, all are lower than 38. None reaches to 38. Everyone is lower. So that means the error occurred in one dimension, only with one dimension. What is the dimension? That is lower. They could not go past beyond that, the total value. So it's 38. Was supposed to be a true value. The literature value was 38.73, but the other values are 35.16, so it's lower. So it is always on the one direction. So it is a systematic error. It's not a random. It's a random error. Then somebody would get 40, somebody would get 39, somebody would get question number 6. Just what does it mean? What does the word say? Tolerate for 5 minutes more. After this, I will take 5 minutes break. So question number 6 says the accepted value of molar mass for methane is 16.04 gram per mole. The following are the result obtained by 4 students in their experiment: Elliot, Chris, Carlo, JD. Elliot got 15.7.05 gram, 13, Chris 15.5 and 10. So everyone is getting less than what was supposed to be the molar mass of methane. Calculate the percentage of error and percentage of uncertainty for this student. Percentage of error. How do we get the percentage of error? That is 16, the true value minus the experimental value by the true value. That means 16, just one thing, 16.04 minus 15.7 by 16.04. times 100%. Okay, so in this way we will get the percentage of error for Elliot, and so for Chris, Carlo, JD, all those things. Percentage of uncertainty. How do we calculate the percentage of uncertainty? Then the percentage of uncertainty is how much uncertain was this value from these total or the mean values, right? So percentage of uncertainty is already, we have already done it for percentage of uncertainty before, so that we just need to follow the equation and put it here so that we will know what is the percentage of uncertainty here. So for Elliot, Chris, Carlo, and JD, we got this thing. Which student has lower precision and high accuracy? If we do all those experiments, all right, we all those calculation, we will see that each of them has different accuracy, different precision. Some will have a very good high precision, some will have the lower precision, but some will have higher accuracy, some will have lower accuracy. So these two combination can be arranged in 4 different ways. So we will see that low precision, high accuracy will have one student who is having the lower percentage of error, all right? Or who is having the lower percentage of error will have the high precision, but percentage of uncertainty is higher. So that means it is not a good accuracy in that way. So we have to do all those calculations to find out who is having a better or higher percentage of accuracy. Okay, as I said that I'll take 5 minutes break. So I'll come back in 10:33, exactly 10:33. And by this time, if you have any question, we can also answer to that. Hello, I'm back. Okay, so we are here and I check that this is only one thing left. Okay, let's go by the, actually I didn't check that how many much is left, otherwise maybe we could finish before we could go for a break. So the question 6, once again, it says that the accepted values of molar mass for methane is 16.04 gram per mole. The following are the result obtained by 4 students in their experiment: Elliot, Chris, Carlo, JD. 4 of the students, they are measuring the things. One got 15.7, another was 13.2, 15, and 10. So this is, by the way, is also a systematic error, right? Because everyone got less than what is the actual value, which is 16.04 gram per mole. So now, percentage of error for Elliot is 16 minus 16.4 minus 15.7, right? We do it in this way. We can find it. We know how to find the percentage of error from Elliot. And for other students as well, how to find the percentage of error. So, for percentage of uncertainty, we see that how much is the tolerance or uncertainty over the total values, that is 0.5 over 15.7 times 100%. So times 100%. So in this way, we will see what is the percentage uncertainty and percentage of error for Elliot, for Chris, for Carlo, for JD, and everyone, right? Okay, so if we find out the values, we will see that someone is having less percentage of error but high percentage of uncertainty. Some is less percentage of error, high percentage of error and less percentage of uncertainty. So in this way, and based on that, the low precision and high accuracy, who will have the low precision and high accuracy? Low precision means who is having higher percentage of uncertainty, okay, but to some extent acceptable percentage of error. So that will have a lower precision, by accurate, quite much accurate to that result. And for high precision, high accuracy will be the one who is having both cases lower value, less percentage of error and less percentage of uncertainty. So in this way, we can find out who is doing better in that way. Which of the following suggestions suggestions that usually can be used by this student to minimize systematic error, and which can be reduced random error in their experiment? Identify the largest contribution, the percentage of uncertainty. This is a good way that if we can find out what is the highest percentage of uncertainty. So by that way, we can reduce the random error. Use the larger sample size. There will be there is a possibility of more random error. Repeat the experiment again. Possibility of reducing, random error, and changes the procedure for instrument where possible. Both systematic and random error is involved in this in this process. We can reduce the systematic and random error. Sorry, we are trying to reduce, right? Evaluate the validity of any assumptions made then it will be, we can remove the systematic error in that way. So and so on. So calibration of instrument, there is evidence suggested calibration error. So by this way we can remove the systematic error. From the answers above, complete the following table about precision and accuracy. Precision is affected by, and accuracy is affected by, precision affected by the random error, and it is evaluated by looking at percentage of uncertainty. Okay, so percentage of uncertainty is low, the precision is high. How to improve? Repeat the experiment since it's a random error, and replace largest contribution of the uncertainty where for which result the contribution uncertainty is occurring, so you have to remove that one or replace it and use the larger sample size. If we do many trials, we can reduce the error and become more precise. For accuracy, systematic error, actually it is affected by the systematic error, and percentage of error will tell us how accurate is that result. So we have to tell us that how to improve that result is examine the validity of the assumption, examine the procedure, or examine that systematic error. So remove the problem that associated with the methodology or with the instrument that we are using it. Calibration, yeah, calibration things that we can do. So this is how we can reduce the error. And for the first experiment, all that we are discussing will be useful for you to consider. And if it is in the report, you consider all these things that we are using it for this preparation or discussion, it will be better for the lab report as well. Okay, so do you have any questions so far? We are done for today. Anyone has any questions so far? All right, it's considering it's a no. So I'll see you tomorrow afternoon for the tutorial class. Oh, sorry, for the lecture 2. Yeah. And okay. So no questions. So yeah. So take care. Bye bye. I'll see you tomorrow. Have a good day.